My name is John Fisher. I'm a major in electrical and computer engineering at the University of Alabama at Birmingham. I'm a junior with a 4.0, and this presentation is dedicated to my final presentation for my class, EE 490, Internet of Things. In this class, we got to identify a need in our lives and then create a solution for that need from the principles that we learned from this class. Now, what I created wasn't for myself necessarily. It was for somebody very close to me, my fiance. More specifically, her bearded dragon. See, this bearded dragon is very needy and is not needy in many aspects. For example, it doesn't even need food for long periods of time, nor water, nor physical comfort or attention, really. But it does need this. It needs 2 heaters, which stay on for 24/7, a UVB lamp that stays on 24/7, and then a UVA lamp that has to switch on for 12 hours and switch off for 12 hours. This can cause some issues. See, I work full-time, and so does Sierra, and my work often causes me to be out for extended weeks. Sierra, she works as a patient care tech at a hospital. She works night shifts. This means that she'll often be out all night and then have to go directly to her classes, and then she'll be gone for far past 12 hours. She'll be out till 3 in the afternoon, so that often means that she'll be out for 21 hours away from this bearded dragon and not able to switch it on and off. She needed to solve this issue, and I saw I could solve it using what I learned from this class. This video is dedicated to the second section of this presentation on project development, scope change, and challenges. Initially, I described to you only one function of this project, and that was remote relaying, to where there would be a 12-hour timer on for 12 hours and off for 12 hours. This lamp would be automated. And then there would be 2 added variables. One could select to manual, and then one could select auto for the control of the relay that is feeding into the UVA lamp, and then an on or off. So once the on or auto or manual has been selected to manual, then you can select whether the light is to be on or off. But this didn't stay the same. The scope actually progressed, and we had to reiterate. We wanted to add data where we could read in the humidity and temperature of this bearded dragon's cage. Remember, I told you that this bearded dragon is very needy, and it needs its humidity and temperature to be controlled pretty tightly. Sarah could read this remotely in the same app that where she's doing her relaying from, the humidity and temperature. And if this humidity and temperature is out of range, then she could tell that there's an issue. As well, adding on to this, we wanted to add a function to where she could actually tell if the light was on or off remotely. Now you might ask, if she can go to manual, then she knows this. Well, what if the light bulb is dead? Then she has no idea of verifying this. And then you might add on to that, well, if the light is dead, then wouldn't the Arduino be dead? Well, if we feed the Arduino from an external circuit, then we can tell this based upon via a photoresistor. See, if we add a photoresistor, then we can create a voltage divider, or we take the voltage across a resistor that is in series with a photoresistor. See, if the UVA lamp is off, then the resistance of the photoresistor would be so high enough that no real voltage would be indicated into an analog point. Well, if the photoresistor was pulling in light from the UVA light, then the voltage across this said resistor would be high enough to where you could actually indicate that the light is on. Now, to help demonstrate this, I'm going to include a elementary diagram that I got to create to help demonstrate this and to help ease any confusion before I begin my video demonstration. Thank you. All right, so this begins the video section of this presentation. And after you've seen the schematic that I've written, hopefully you can get a better picture of how this solution is actually laid out. And before I begin talking about this solution, I want to show you how the old way we did it. initially there is this switch right here that actually controls the UVA lamp. And that is, I guess you could say, the switching section, which will then become the relaying section. Here you have a digital meter that is taking your temperature. And then over here you have an analog gauge that is pulling in information on the humidity of this gauge. These are two different values that are very important to maintaining this lizard's health. So how did I automate this? Well, to begin with the relaying section that you could find in this schematic, you have the actual relay right here. This relay is currently off, and then this is wired in to the Arduino, which is connected to the Wi-Fi. And then let me pull up the Arduino Cloud app right now. So this is the Arduino Cloud app, and you can see here there is the relaying section that I've set up, and then here's some data that we're pulling for the temperature and the humidity. I'll talk about this soon, but first I want to continue with the relaying section. So currently there's two variables that I'm controlling. One is called a handoff auto, which is just a fancy industrial term for saying manual or automatic. Currently it's set on for manual, and then there's another variable that is dealing with on or off. So once you set to manual, then you can control this variable, and that's, of course, if the cage is on or off. So currently it's set to off, but then I can turn it on and then off again. Or I could go back to auto, and this goes back to a 12-hour timer, as I've described many times before, on for 12 hours, off for 12 hours. So if I go back to the original timer, you can see it's going to turn back on. I believe this is it for the relaying section. Now I'll talk about the data section. So as I said, there's nothing automated for the temperature or the humidity. How this is being automated, though, is via this little device right here. It's called a DHT11, or humidity source. Essentially it's powered from 5 volts to ground, and then there is a serial communication bus that is feeding to a digital point. From this DHT11, we're also getting the temperature and the humidity, which you can see right here. As well, there's another variable that we're getting a read status from. That is the status of the lights. So if I manually turn this off and you look at the light status on the Arduino app, you see that it'll shut off and it'll shut back on. The purpose of me implementing this light status, and I think I described this earlier, was kind of to prototype a solution. So there's some sort of redundancy for my fiance to know, whether the light is on or off. This is so when the Arduino is fed from a separate circuit, we can get reliable information on the status of the light. And then this also ties back to the humidity and temperature data on whether the heaters are actually on or off, because the heaters and the lamp would be fed from an external circuit. I could implement this, well, not implement, I could go further with this, and then I could do some sort of alarming or notification to Sierra. So if there is an actual issue and the heaters are dead or the lamp is dead, then she can call a family member, and then they can come up here and then they can replace a necessary bulb. Haven't implemented this yet, but if I decide to go further with this in the future, it could be done. I think that's everything. To wrap up this video, I really want to talk about the highlights I've gotten from this course and why this course, but also this project really matters. Now, to begin, I want to start with the course learning objectives. I think this would be a really good start. And from this, there's 5. 4 of them deal with the finer details, and then the last one, which is the one that I want to focus on, is why any of this really matters. So to begin, you'll have certain course learning objectives that are more detailed and technical oriented. You'll have explain IoT architecture, connecting IoT devices to cloud services. For my example, it was the Arduino Cloud. Implementing and troubleshooting related protocols. I had to deal with some serial communication protocols with my humidity sensor and getting that pulled in using C++ scripting. But the last one, as I described, which is the most important, is presenting a functional IoT solution using complete documentation. And you haven't seen much of the complete documentation. That is for my professor, who is watching this video right now as well. What matters is that I took all of this technical information in, and I was able to go through the engineering design process of identifying a need and then building a prototype. I didn't build a final solution and then market that solution. But if I were to go through the complete cycle of engineering design process, I would. And I could build upon that. I could go and try to market this solution, but it's not exactly my passion. My passion is not exactly building lizard cages and then automating them. But nonetheless, I now have this skill, and I now have worked out the reps of taking a lot of technical information, actually not just from this course, but from my degree, and creating a solution, which is why I am in school in the first place. Thank you.